The next question says 35 grams of an unknown liquid is poured up to a height of 15 centimeters into a cylinder with a radius of, and the cylinder has a radius of 9.5 centimeters. Find the density of the liquid. So go ahead and pause, try to solve this one, and when you're ready, unpause. Alright, so let's try to get the answer. So you have 35 grams, so that's mass. We have 15 centimeters. Centi is 10 to the minus 2, so 10 to the minus 2 meters. So that's the distance, which I'll call x. And we have 9.5 centimeters again, so 10 to the minus 2 meters, so that's another distance x. And we're trying to find the density. So let's try to interpret this problem. So you have a cylinder, and the cylinder is completely full with this unknown liquid, and this liquid has a mass of 35 grams. And now the cylinder, let's see here, the height is 15, so the 15 is going to be the height of the cylinder h. And the cylinder has a radius of 9.5, so the radius here is 9.5 centimeters. So this is actually r. And we want to find the density. So density is defined as mass divided by volume, and specifically for a cylinder, the volume is equal to pi radius squared over the height. So we can just plug in here. So the density is going to be the mass, which is going to be 35 grams. So here, I'm just going to automatically convert 35 grams into kilograms. That should be it's going to be 35 times 10 to the minus 3 kilograms. And divided by pi, and divided by the radius, which is 9.5 times 10 to the minus 2. Radius gets squared, and multiplied by the height, which is 15 times 10 to the minus 2. And that will give you a density of 8.2 kilograms per cubic meter. Alright, so try this next question. It says a beam with a rectangular cross-section of 22 centimeters by 24 centimeters and a spring constant of 300 Newton meters is placed under a tension force of 925 newtons. What is the pressure exerted on the beam? So go ahead and pause, try to solve this one, and when you're ready, unpause. Alright, so let's see what we have here. You have 22 cm by 24 cm, so that's 22 times 10 to the minus 2 meters by 24 times 10 to the minus 2 meters, so that's a meter squared, so that's going to be an area. And you have 300 Newton meters, so that's the spring constant. And you have 925 newtons, so that's a force. And we're trying to find the pressure. So here, we had more information that we needed, pressure. So what we have is there's a beam. The beam has a cross-sectional area A. And it does have some stiffness, and there's some force applied across the area, but all we want is a pressure. So the pressure is defined as force over area, or in this case here, it's going to be plugging in. The force is going to be 925 newtons over 22 times 10 to the minus 2 multiplied by 24 times 10 to the minus 2. and that's going to give you a pressure of 1.75 times 10 to the 4 pascals. So here is the next question. So go ahead and pause and try to solve this one. It says, what is the pressure at the bottom of a 50-meter deep tank of water? So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, so let's try to solve this. There's only one number, 15m. That's the distance, which I'll call x. And now let's try to draw what's happening. So this is a body of water, and you want to find the pressure down here. So this is actually the depth below the surface, or just the height y. So you're trying to find the pressure down here at the bottom, and this is water, so we have to include the density of water. So the equation is the pressure at the bottom is going to equal the density of water multiplied by gravity and multiplied by the depth below, which I'll call y. And this is just a plug-in, so the pressure at the bottom is going to be density of water is a constant, that's 1,000, and g is another constant, 9.81, and the depth is 15, and that will give you a pressure of 1.47 times 10 to the 5 pascals.